Hello, you're welcome back to my channel, Physics with Chaos. In this lesson, we're going to consider hearing, decibel scale, and risk. You're welcome back. Hearing, decibel scale, and risk. Our ears are very sensitive to sound. Most people can hear very quiet sounds and also very loud ones. We like to hear sounds like music and the voices of our families or friends. However, there are sounds that are undesirable, and these sounds are called noise. Noise are basically sounds with no fixed frequency, the decibel scale. The intensity of a sound is measured using an instrument called the sound level meter on a scale called the decibel or the dB scale. A sound with high intensity is louder and will have a higher decibel. Now, similar to what we have when we measure the length of something using an instrument called the ruler or a measuring tape on a scale of centimeter or meter, the intensity of a sound can also be measured using an instrument called the sound level meter on the dB or decibel scale. Here we have a normal conversation on a sound level meter of about 66.8 dB. Okay, now we need to note that a whisper is about 30 dB. A normal conversation is about 60 decibel, and a motorcycle engine running is about 95 decibel. When you are exposed to sound that is above 70 dB over a long period of time, it may gradually lead to hearing loss or damage of the eardrum. Loud noise that are above 120 dB can cause immediate harm to our ear. Now, let's have a quick review of loudness or intensity. Recall that in my last video, we talked about loudness, how it's related to amplitude. The higher the amplitude in an oscilloscope, the louder the sound. So loud sound will have a high amplitude and hence a high intensity. Intensity is basically an amount of energy that is transported past a given area of a medium in 1 unit time. Okay, so in that case, we can say that intensity is the energy over time times area, or intensity is the power of the sound over area, since energy over time here is the same thing as power. Okay, now here we have two sounds, a soft sound or a quiet sound and a loud one. This is quiet because the amplitude is smaller, it's very small, and this is loud because the amplitude is larger, okay, or longer. Now we should note that loud sounds will have high intensity and will be heard at a longer distance because they carry more energy. Okay, intensity and decibel scale. The decibel scale is not like a ruler. It is a scale to measure the intensity of a sound. So every increase of 10 decibel increases the intensity 10 times. That is what noted. Okay, so this is how this sound is different from our regular measuring device like a ruler. Now, If we assign 0 decibel to the lowest sound the ear can hear, which is known as the TOH or the threshold of hearing, then for 10 dB, the intensity will be increased by 10 times the smallest sound that we can hear. For 20 dB, then the intensity should be 10 times 10, which is 100 times the smallest sound we can hear. Now for 30 dB, we have 10 times 10 times 10, okay, which is 1000 times. Now in this case, we have the lowest audible sound, which is 0 decibel, and assigned as 1 or 10 to the power of 0. Then the rustling leaves will have 10 decibel and then assigned 10 to the power of 1, or simply 10 times the intensity of the lowest sound. A whisper, which is 20 dB, should be 10 times 10 or 10 to the power of 2. A normal conversation, which is 60 dB, should be 10 times 10 times 10 times 10 times 10 times 10, or simply 10 to the power of 6, or 1 million. Okay, so we can keep going on and on like that. This is how the decibel scale work. Okay, example on intensity and decibel scale. In this question, we have a mosquito buzz is often rated with a decibel rating of 40 dB. Normal conversation is also rated at 60 dB. How many times more intense is normal conversation compared to the mosquito buzz? So what we do here is we subtract the difference between the normal conversation and the mosquito buzz. Okay, so this is what we have, 20 dB. And remember, 20 dB is the same thing as 10 times 10, or simply 10 to the power of 2 times more intense or more louder than the TOH, the smallest or lowest audible sound. Okay. Question 2. How much louder is 80 dB compared to 70 dB sound? Similar to the first one, we subtract the 2 to get 10 dB. So 10 dB should be 10 times louder. Okay. Another example here. The table at the right represents the decibel level of several sound sources. Use the table to make comparison of the intensity of the following sounds. How many times more intense is the front row of Smashing Pumpkin concert than the 15th row of the same concert? This is the front row here, and this is the 15th row here. First, we subtract to get 10 dB. So it means it's going to be 10 times more intense. Now, to compare with the second one, the average factory, we are comparing the first with the second average factory. We subtract 110 minus 90. That gives us 20 dB, and 20 dB is equivalent to 10 times 10, or which is 100 times more intense. Okay, guys, try to work out the rest on your own. Activity and decibels value. Now, in this slide, we are going to check out certain activities that are way bigger than 120 decibel that we should, stay away from, or have certain protective measures taken to avoid the possibility of having, or the probability of having an ear defect. Okay, so we have these activities here, and decibel values are assigned to them, and what the sounds are like. In this case here, we have 50. This activity, normal speech, is about 60 dB. It's a normal quiet sound. Here we have a traffic at a junction. So this is about 80 dB, and it's quite annoying. Okay, so we should stay away from sounds like this, especially for a very long time. In this case, we have vuvuzela, which is about 120 decibel. This can actually damage our ear after some time. And here we have a jet engine 100 meters away from us, and the decibel value assigned to this is 140 dB, and it's a loudest recommended level with ear protection. Here we need to have ear protection if we walk close to or we're close to this kind of activity. Okay, activity and risk. When scientists talk about risks of an activity, they consider the probability that something bad will happen and the consequence if it did. Sound with high decibel can have a grave consequence to us, so it's important we know the type of sound that is worth risking. Now, recall that sound exceeding 120 dB can cause an immediate ear problem, and sound that are bigger than 70 dB can damage the ear after hearing for a prolonged period of time. Okay? Taking risks in an activity. We often take risks when the consequences do not seem serious. Listening to music or going to concert may not seem risky, but it's a probability that your hearing will be damaged by a loud music. That probability gets bigger the longer you listen to music. Okay, so for those of you using the earphone or earpiece to listen to music, you should regulate the time you listen to the music, especially if the volume is way bigger than 70 dB. What can damage your hearing? The risk of hearing loss depends on two things. Depends on the length of time you are exposed to the sound or the number of decibel. Recall that we mentioned that 120 dB can damage the ear immediately, and sound exceeding 70 dB can damage the ear after hearing for a prolonged time. So, what do we do to reduce risk? Reduce the risks. Number one, we need to reduce the sound level if possible. So if you're listening to music, you need to tune it down. Two, shield the ear using ear defender from the source of the sound, like what we have here, okay? Three, increase the distance by moving away from the source. Four, reduce the time you spend near the source of the sound. These are ways we can reduce the risk involved with loud sounds. Okay, guys, I believe you enjoyed the video. If you like the video, please leave a like by clicking on the like button below. Share the video and subscribe for more videos like this. Thank you for watching.